So this talks about content steering, and what we'll see is it's much more intro level. We are just starting this journey. We're not even in production with it. We're still figuring things out and understanding the spec. And as you'll see here, we'll outline several things about it. But first off, right here. So I'm Lyle Scott, Director of Engineering for the Video Delivery and Experience Group at Paramount. We're the multi-CDN team within the company, or most of the company. We are responsible for multi-CDN orchestration, traffic steering, and observability. This fits into our paradigm really well. I am not from this industry, from this world, but I work with several people that are. So I'm still drinking from a fire hose, understanding this stuff. So excuse my terminology if I get something wrong. Yeah, so let's get started. Let's see. Yeah, so really the purpose of this talk, like I said, is to educate people on content steering. We'll touch on some implementation specifics at Paramount, but like I said, we are really early in this journey. So I was talking to Dan here. We'll do a part 2 later in the year when we get something more mature and out in the wild and really get some real feedback. What is content steering is on the agenda, but to understand content steering, I think it's yeah. All good. I think it's important to contrast it with what we have today and some of the drawbacks there, and then we'll get into how HLS and Dash handle content steering. Like I said, some implementation notes, and then what is content steering? It's really about player-driven CDN selection. As you'll see in the next slide of how we do it today, it's quite turned on its head. It's about the player reaching out to a central URL. That URL essentially drives the steering rules, and then the client really evaluates those rules and takes its own feedback and really uses those rules as a guideline, and then makes the final decision on how to play that content and what to play it over. It is a standards-based approach. Like I said, HLS and Dash handle it very well. Even doing this talk, you could see that it's essentially the same thing between the specs. Dash is a little bit more fancier in some aspects, but it was nice to see it's kind of the same. It's also about providing on-the-fly manifest manipulation. What I mean by that is, you're taking a little bit of the logic away from what could have been on the manifest generation server, and you put it into the clients, and we'll see that kind of in action with some other things. Yep. Yeah, and is this fine? How about this? All right. Put it right here. All right. So can it, replace, DNS-based multi-CDN decisioning? Verdict's still out, and player compatibilities. Talking to Dan, at least, I'm not from that world. Seems to be pretty caught up these days. So what we do today is very much rooted in DNS-based decisioning. What that amounts to is you have a streaming multi-CDN URL that a client, that's involved in playback, when they make a DNS request for that host, it actually goes to an application, a DNS application, to evaluate a set of rules and logic to then return the most optimal answer. So that could be, you come in on a multi-CDN URL, you are a user in United States, in New York City, on Comcast. We will have the top there, the decisioning pipeline synced to that application to really take your client details, map it into that performance map, and return what we think is the most optimal host name for you to use, which maps to the CDN that theoretically has the best performance, or what we'll talk about in a second is the best business rule to make that request. So the top here, I just want to go ahead and briefly mention it. It's a little bit outside of the scope of content steering, but it's important to just understand, like I said, what a decision is and what's kind of involved in that. None of this really changes from DNS-based decisioning versus content steering. So on the top there, you have a realm client. It's consistent. It's in our case at least, it's a bit of JavaScript on a bunch of our Paramount websites and pages that essentially loads when somebody's watching a video or just visiting a web page. And what that little piece of JavaScript's doing is it's sampling assets across different CDNs, and as it does that, it records how that went. TTL, TTLB, availability. Was it up or down? How fast it was, where that client was. Country, state, ASN level, and that's how you start developing that map, that performance map of the internet. And then you can take, sky's the limit. It's not all about performance these days. Like there's a lot of CDNs that, especially domestically in the US, that perform really well. So again, it's less about performance and a little bit more about taking advantage of business rules. So it could be a Tetris of, if we meet these commit tiers with this CDN, it will unlock cost savings. So aim for that, and then you can model that, months out to say if you take, if you use this kind of pattern to fulfill those goals, you can save this much money. So that's what it's turning into these days, less about performance, more about business rules, similar to that. Anything else to say here? And that's kind of DNS-based decisioning in a nutshell. So like what is bad about it, and why do we want to kind of move away from it and go into content steering? As a client, when you make that DNS request to that DNS application to take all your details into account and then map that into the best or the optimal CDN for your use case, it requires a lot of client information to be passed along with that to make a good decision. And what we're finding is more and more so, it's just an issue, due to privacy, due to different implementations at resolvers. That information is lossy and lossy, and then we can make not a great decision. Sometimes the information is not there at all, so we pick something more random. Sometimes it's actually the DNS resolver's geolocation information rather than the client's geolocation information. So you're actually handing out a decision that doesn't really pertain to the user. And then, at the end of the day, it's Matt Ball, a colleague of mine, a CDN architect, he made the analogy that it's like steering a cruise ship. Because when you do have a problem, and you change that performance map to say, hey, people in New York City, on Comcast should actually use this CDN rather than the CDN that they were on, that can take a while for it to take effect on the client due to TTLs, due to just a variety of things. They're not going to get a new decision unless they make that DNS request. And what we'll see is content steering is it turns that on its head and it really gives you that speedboat rather than a cruise ship. Generic content steering concepts. You have a content steering server. When the player starts, it hits a server. It gets the manifest back, a content steering manifest. That content steering manifest then is the essential instructions to the client or player to then reach out to another URL. We'll kind of go into these other things. And what you'll see here is the content steering server you start at can actually change depending on what the manifest server tells you. So then you have a pathway or a service location. It's essentially just a label on the variant streams to categorize it some way so that the manifest can tell you, hey, play these things. And that pathway is then mapped to usually a different CDN or a different scenario, we'll say. So pathways can be penalized, depenalized, and if they're really bad, they can just be done away with. So there's, that's a client responsibility to do that. So the server is essentially offering up the guidelines for the client to operate in, and then the actual client is really taking a lot of factors into account and making the best decision for that client. And that's what's missing from DNS-based decisioning. It's really like a macro level steering, broad strokes type scenario where content steering gives you those fine details of that client. Telemetry via query parameters, pathway is a requirement. So when playback starts, the player is constantly reaching out to this content steering server based on the TTL from the previous manifest. The manifest, and then when the server reaches out to the next manifest, it includes the pathway that it's on. So you can do kind of neat stuff with that. So on the content server, you can say, okay, well, I told this person to use this pathway, but they're actually using this pathway. And then you can kind of use throughput. Throughput is an optional parameter, kind of best effort thing. But you can start making those, client-based decisions to say, okay, you can even use this for kind of back propagation to your decisioning engine to maybe mutate your rules. To say that, okay, I'm constantly telling this client to use this or to prefer this pathway, but they're always using this other pathway. And based on these throughput details that I'm getting, you can make the assumption that maybe people on the highest bit rate ladder should actually use a different pathway, or vice versa. And then going back to just being able to switch on a dime when things do change. That's you can switch them as soon as something bad happens. I mean, there's still a TTL involved, so we'll say it's 30 seconds, but as soon as that client gets that manifest, it will switch then and there to another pathway, aka another CDN. And just miscellaneous kind of items. Say you reach out for a content steering manifest and you get a 410 gone. That just means the server's just like I said, gone. So the player just falls back to essentially ignoring content steering. And then there's back off. You can do 429 both in Dash and HLS. It just means, hey, back off, let the server get some breathing room. Again, we do not have that in the DNS land. TTLs are very monolithic for that host name, at least in what I deal with. So it just gives you a lot more flexibility, a lot more power, and just really allows you to personalize everything for that client. This is the steering manifest spec. So again, you'll see how it's done in HLS and Dash, but this assumes that the player has started and it has content steering, content steering server defined, and this is what it receives back when it reaches out to that server. And these are the rules that essentially get evaluated by the client. So you have a version just number 1 right now. TTL is just what you think it is, how long this manifest is really good for in the client, and that plays into kind of fallback and retry rules. The reload URI. So going back to okay, you start up the client, it starts playback. It's starts on one content steering server. This reload URI can actually redirect you to a different content steering server, or it can start applying other URL parameters to that same content steering server. So as you'll see here, or in a minute, you can get really creative with that. Pathway priority is just, what do you prefer? Say you have Akamai, Fastly, whomever, top is most priority, bottom is less priority. And going back to that, still a server-based recommendation, the client makes the final say on how that goes down based on just the feedback that it gets from those pathways. And then pathway cloning, there's its own slide. It's a little bit fancier of a payload, but it's extremely powerful. And going back to, you can modify the manifest quite a bit on the fly, and taking that away from the manifest generation server. Pathway cloning is pretty powerful in that regard. So just a small steering manifest example. This is what it looks like in real life. So this reload URI kind of illustrates, say you started on foobar.com/steer as the content steering server. The reload URI can then append those details, whatever they may be, right? This is coming from a server, so when that client makes that original content steering manifest request, you can get all of their client details. You can say, hey, this person's in Brazil. I want to run this experiment. You can decorate, to your heart's content, the URL parameters with just information you can riff off of in logic on further content steering server requests to just make really good use out of that bidirectional feedback. Again, going back to more a monolithic DNS steering approach, you don't really get that. Pathway priority, we already talked about. That's it. So going back to pathway cloning, it's an object of the original manifest. There's a list of them. It's just a rewrite, essentially. So it has a number of use cases. I think you can get really creative with this. So you have a pathway defined in your manifest. Say it's for one CDN, and you actually want to duplicate that for 2 or 3 other CDNs. You can use this to really do that at a variant or rendition level. You can say, okay, so this host is, do I have an example? I'll switch to the next slide. This is a good example. So you're essentially cloning CDN A, and then you're making these changes to it. So this base ID is what you're cloning. The ID is the new clone. And then you're saying, okay, the URI replacement, replaces host, replaces param, and only apply it to these rendition IDs of audio 37262. And what that's really powerful for is, going back to just getting more detail and having that power to decorate those URLs with a variety of parameters that are just useful to your use cases. Going back to, decisioning is not necessarily about returning the most performant decision. It can really be involved in business logic. So it's just more powerful for all that stuff. We work across business units at Paramount. So we service CBS Sports, CBS News, Paramount Plus, just a whole variety of folks. So there's a whole lot of need to do different things across business units. They're always doing A/B testing. They're testing new things, and this is just I see a powerful tool for them to build upon. Getting into like an HLS example, this is what it looks like. So at the top there, you have the content steering server. This is the URI, that initial hit of the content steering server to get that initial manifest. You have the pathway ID at the end. That is optional. It just means like this is the pathway you're starting on, and that's it. And then your variants are decorated with a pathway ID, and that's going back to that pathway manifest. You get a prioritized listing of pathways. This is where it comes. This is how it maps back into a variant. And then in Dash, looks quite similar. And yeah, it has a few more expressive parameters. So query before start is kind of neat. So it's essentially saying, do you want to reach out to the content steering server? I think it's before playback actually starts, I believe it is, or not. And then default service location is just like obviously the pathway you're starting at, and then you have multiple pathways defined up there. Just to put it all together, just put in the bottom right the total URL that is built. Again, it's including the pathway in the request to the manifest. Content steering server, and it includes throughput as well, in this example at least. So this is some more advanced use case. So going back to just being more specific, so Dash allows you to steer different types of content more fine grained. For example, you can steer the manifest a little bit different from ads, which is at least what I gather. You can't really do an HLS. You can kind of use and abuse reload URI to do that, but not like in the sense of sending all your users on an ad break. But I just thought this was kind of neat because I see a lot of use cases for this. And also, you can not only use, well, let me back up. So you can use different CDNs. Maybe you have a budget CDN for manifests and a heavier duty, more expensive CDN for segments. The kind of list goes on. Yeah, I'll skip over that. You know, origin support for content steering. So again, going back to the needs of Paramount, we service a lot of origin types. You know, a lot of it's AWS Media Store, Media Package, now S3, but we do generic origins, like, you know, sky's the limit, depending on who you talk to. So just getting started has been an issue, just from the fact that, you know, somebody or something has to decorate that that manifests with all the content steering details that we've talked about. That's kind of a moving target. So you know, best case scenario is kind of done for you. We've not encountered that case. I wish it was more popular. You know, you typically are stuck with like a decorator service, kind of man-in-the-middle proxy manifest service. That's what we've kind of gone with, at least for the R&D phase. We are able to use Fastly VCL in some capacities at a shield layer. So we were hoping we could just, you know, throw up some VCL, just do kind of, you know, fetch the manifest from the origin, make those substitutions, you know, kind of directly in the request without any dependency on yet another service to deal with. You can't really do that in Fastly VCL, at least without dipping into a computed edge function. So you can actually do that at other CDNs, Fastly Akamai, you know, CloudFront. They all have their kind of edge compute analog, and that's what you kind of use to, you know, if you really just want a quick little service to do the manifest rewriting, or you can just, you know, stand up your own microservice. And then what I was talking to Dan about, like, can the client just do it? And then, like, you know, it's just a facility of the client. But, you know, from a client perspective, I think the idea there is to keep it really thin. They're getting pretty thick anyways. Everybody wants their SDK on our client at least. But, you know, there's some device power issues, etc. It's not a great idea, it seems like. So traffic shaping. If there was a Apple conference that kind of went over a bucket list strategy. I'll kind of illustrate it here. We riffed off that a little bit, and we're giving that a go. And this is kind of fresh off pull requests. Hopefully I don't butcher it. I was trying to kind of gather the logic together to figure it out myself, even this week. So, you know, what does the new architecture kind of look like in a content steering scenario? You know, that top part that we showed earlier, where it's producing a essentially stacked rank map of you know, CDNs and, you know, mapped by country, state, ASN combination. None of that changes. What's great if you kind of do it right is your decisioning pipeline, the artifact that it produces. It could go to a DNS decisioning service, but it could also go to something like this. It could actually even go to a manifest, you know, manifest manipulation service to just go ahead and replace the host then and there. The point is if you do it right, you can have a reusable artifact of your decisioning pipeline in all these cases, and that's kind of a solved problem in a way. So you just have to worry about how do you propagate it at scale throughout the globe, you know, in your distributed architecture. So some of the concepts that we've been focusing on is a request context. So when the player reaches out to the content steering server and it receives the manifest, that initial request, again, it can be on a different, you know, content steering server altogether. It doesn't really matter. But that is really figuring out those client details. And in our world, like I said, we have a lot of streams. It's not like we're just serving one stream and applying this all to one stream. So it's about, you know, adding a lot of those stream details to then figure out what should the you know, options be for CDNs, and how does that map to that stack ranking and all that stuff. So it's just a really business kind of context state that we can produce, and then send that along to the reload URI of that first manifest request, and then it's kind of there for further requests to use in those evaluations. There's two concepts there. There's a traffic allocation and a bucket list. So the traffic allocation is to the right. It's really just a serialization of that stacked rank mapping You see the USCA 7922, so that's US California, and then 7922 is the ASN, the network that they're on. And going back to what the Doppler pipe or the decisioning pipeline even does, right, is producing that stack rank map for those keys. And then you'll see the one below it without a state or sub-region, and that's just for different fallback scenarios where we're missing information. So that helps define the performance map within those locations, and then you have to think about how do you do that traffic steering. And say you want to run 50% one CDN, 50% another. In the DNS decisioning case, you really depend on your DNS application to do that. NS1 does that, Sidexis does that. You're on your own now, so you have to start implementing these things yourself. So we went with a bucket list approach. So if you can imagine just a table of 100 buckets, each bucket is a CDN list, which translates into a priority list. And the user comes in, random number generator, they get mapped to a bucket, and that's the CDN or the priorities that they receive, and then the client takes it from there. So that's the general approach in a nutshell. I think the more interesting things about a bucket list are really as the traffic allocation changes. So we want to, we change the percentage. We're in a live event. We want to take some heat off this CDN, so let's swing it to another CDN, or just add a third CDN. How do you change that? And that's kind of what we've even been working on recently is how do you do that without really affecting the least amount of people and making them do a midstream switch to another CDN. And we do that by essentially keeping state on how many, or it's a variety of things, I believe. You could take the approach of how many people are mapped to each bucket, but that gets a little bit murky when you think about CDNs being in the mix, which we haven't gotten there yet. I'm sorry, CDNs for the content steering manifest. Or you can think about it as when is the last time this bucket has switched CDNs? So you can take the one that's actually switched the least, for example. So theoretically, you're not flinging people around to different CDNs, or you are doing it less so in that case, because with this power becomes problem of just flapping and sending people around to too many different CDNs in their session, and that's something we kind of try to battle. So with that, there's, just going back to failure and redundancy, there's essentially an onion of those traffic allocations and bucket lists. There's a baseline. Baseline's really just configured from the business, either at a global level or some business units have their own steering strategy. So that's just like kind of baseline, always there. We always have something to fall back to. And there's a long-term and a short-term, just feed there. So the long-term is, in hours. So that's a reasonably good assumption to use. If the short-term allocation for some reason isn't there, it's a different pipeline. It's a pipeline that's meant to run very fast and efficiently, because we want essentially, the short-term allocations are from the last 2 minutes. So that represents like the edge of what we know is optimal. But like I said, if anything goes bad, it'll have something to fall back to that somewhat makes sense. And then if all else fails, there's always a baseline to fall back to, so it can figure out what to do. And what's next? I was hoping to come here with an interactive demo, but we're about a week or two away from that. What I presented here is kind of our speed run through. We didn't want to just do content steering without any like traffic steering or anything. So we kind of took the approach of figuring a lot of this stuff out first, thinking about some architecture. It's not applied yet, but we're to the point of putting it all together, kind of the last 5% problem of having something working end to end, hopefully integrate with Dan's team. and you know, we have a demo, an interactive demo. If you've been to like content-steering.com, it's similar to that. Likely be private, but I look forward to coming back with a lot more production experience with this stuff and some more interesting topics to talk about. And you know, it's what we've kind of aimed to build is quite stateless. That bucket approach mostly speaks to that. But you know, going back to those reload URIs with the session details and really the opportunity to throw all those parameters in the URL and use in different rules, I think that's where the sizzle of content steering is. It's that flexibility, and you can get really creative with solutions, and that's the stuff I'm really interested in digging into, and just learning more and use it as we use it more. And we are hiring, kind of low on staff at the moment, but we can fix that now. Do you want to talk about this?
Sure, that was awesome. So I'm just going to add a little more to this. Hiring at Paramount, that's not heard of, so that's great. We are starting to hire again. Things are changing. Where can you find this today? This is in all the major open source players, implemented across the board. There are a couple demos. I can share those out if people are interested in them. We will bring back the demo that we were trying for this talk, maybe in the October call at the end. But more importantly, I think all the modules inside of here for content steering use part of CML. We have CMCD integrated. We're talking about CMCD into the steering service to help change, you know, maybe last mile decisioning that they may not be aware of. But the Common Media Library is a passion project for me and one of my employees, and it's about building out these things like content steering in a spec that people can bring into their own players, into their own industry. So all 4 of those players are eventually going to have the full content steering module. Right now it's using pieces and utilities. This will be our first actual item that we're putting in there that's functional in the full sense, a fully complete functional system. So we're making sure that we do it correctly. And we are using the Common Media Library internally and building our own entire CMAF-based player outside of open source for the first time at Paramount's history. So if you're interested in Common Media Library and contributing to it, we have a ton of folks from around the world, from Cast Labs, from Bright Cove, formerly Bright Cove, and some other folks, you know, a lot of folks around. So we'd love to have people from Iridetto, from other places that can contribute. It's not just JavaScript. We are writing in native languages as well for other aspects. So thank you very much, Lyle, and we can go to questions. Are there any questions for Lyle?
So what about ExoPlayer? It's not in the list here. Is there something blocking ExoPlayer, or what's going on?
I'm biased to JavaScript. Yeah, ExoPlayer has this implemented as well, per Will, right? He has asked for, Will asked for content steering across all open source projects. And ExoPlayer is also there. I should have put that in there. This was made today. So thank you. Any other questions? Otherwise, we'll take a quick 5-minute break and, yeah. It's under the player and playbacks group it's a separate call called Common Media Library. It's once a month, and it's fully integrated into the SVTA docs and everything else. All right, thank you again. A round of applause for Lyle. Yeah, thank you very much.